Okay, so starting off there, that's the Leaving to Ordinary Level 2019, Paper 1, Question 7. So it's the first long questions. A camogie goalkeeper on a level pitch hit a ball straight up into the air. The path the ball travelled can be modelled by this function, okay, where t is an element of r, okay, where t is time in seconds from when the ball is hit, and f of t was the height of the ball in metres above the pitch. The ball landed on the ground without being hit again. What is the height of the ball when it is hit by the goalkeeper? Okay, so this is a typical functions question. They're giving you a load of words, which makes it look complicated, but it's actually very easy, right? So the main thing that we need to know there is that t is equal to time, okay? So t is equal to time, okay? And this function represents the height of the ball, so f of t represents the height of the ball. So if you know that, then the rest is easy, right? So f of t is the height of the ball, and it's the height of the ball, and we want to know what's the height of the ball when it's hit by the goalkeeper. So when it's hit by the goalkeeper, time is equal to 0. So time will be equal to 0. So what we do is we just take this function, and instead of putting in t, we can put in 0. Okay. So take the function. Instead of putting in instead of putting in t, we can put in 0. And if we put 0 in there instead of t, it'll give us an answer. So f of 0 is equal to -4 times 0 squared plus 16 times 0 plus 1. And all of these, because we're multiplying by 0, they'll both turn into 0. So the answer there will be equal to 1. And that year, that was worth 5 marks. Just to be 100% sure, we should be saying 5 or 1 metre because it's in metres, okay? The next part of that question is graphing the function, right? So in order to graph the function, what you need to do is you need to input it into the calculator. So start off by turning on your calculator, press the all clear button to clear everything. Okay, go to menu, go to across there the table one. Okay, so we're going to input a table, so equals, and you'll see f of x comes up. So what f of x is just your function. So we have f of t. It just means f of x just means the function of an unknown. In the calculator, it's saying that the unknown is x. In the actual exam paper, the unknown is t, but that makes no odds. So we can just put in minus 4x, okay? Minus 4, and x there you can see is the red writing in underneath the, it's the second function. So we can press alpha, and we can press x to be squared, okay? So I need to square that, so to square it, okay? Then I need to add 16t, so plus 16, and instead of t, I'm going to put an x, so alpha x plus 1, plus 1. And that's my function there. You can see that I've got the function here. So I've got the function here. That function is the same as the one that I've just input there, except for instead of t, I'm using x, okay? So if I press equals, it asks me for g of x. Now, that would help if I was graphing two functions, I could put in what g of x is, but in this case, I'm only graphing one function, so I'll just press equals again and go straight through. So it wants to know what we start at, and what we're going to start at there is 0. And press equals. What we end at, so if we look there, this table ends at 4. Okay, so you can see there the table ends at 4. So I'm going to have to end at 4. Okay, so end at 4 equals, and step. What step means is how much is it going up by each time. So how much is it going up from 0 to 0.5, from 0.5 to 1, by 1 to 1.5, 1.5 to 2. So you can see there it's going up by 0.5 each time. So we put in 0.5 and then press equals. So that's done, so we press equals again. And there's your table. So you can see the first value there is going to be 0 and 1. Okay, so I can put 1 in there for when my input is 0, my output is 1. Okay, Similarly, I can go down there and look at my second input. When my input was 0.5, my output was 8. Okay. The next one there is when my input is 1, my output is 13. So we can fill in that chart there now, right? So I'll just bring that down there and we can fill in that chart. And how we fill that in is we just put in the values. So 0 and 1. So we should have got 1. 0.5 and 8. 1 and 13. 1.5 and 16. Okay. 2 and 17. 2.5 and 16, which is given to us, so we know we're doing this correct. 3 and 13. 3.5 and 8. And 4 there and 1. Okay. So we can see there at this shape, we've got 1, 1, 8, 8, 13, 13, 16, 16, 17. So I'm expecting this to be quadratic, okay? Okay, so the second part of that question asked you to graph it. So you can start there by graphing that, and you've got 0. So the time is obviously this axis. So I've got 0 on my time. So 0 on the time would be here. And I have to go to 1 on the height. So the height has gone up 1. So that's going to give us that point there. So we'll just plot that. Okay, the next one is 0.5 and 8. So if we go 0.5 on the x-axis, that's halfway across the x-axis. And if we go up 8, that'll be there. The next one is 1 and 13. And 1 and 13 is going to be here. 1 and 13. The next one is 1.5 and 16. So 1.5 and 16 is going to be here. The next one is 2 and 17. And then we'll have 2.5 and 16. We'll have 3 and 13. We'll have 3.5 and 8. And we'll have 4 and 1. Okay, so we just need to be able to plot those points and fill in our line. So there you have it, right? And for completing the table and plotting the graph, there was 20 marks. So that brings us to the next part. So the next part there says use your graph to estimate, okay? And it says show your workings on the graph, okay? So that's important. The length of time the ball was in the air from the time it was hit until it landed on the ground. So from the time it was hit until it landed on the ground. So what we need to do there is we need to look at the graph and we need to see how long it took from when it was hit to when it landed on the ground. Okay. Now we can see there on the graph that it was hit here at 0 seconds. Okay. And the time that it was up in the air, it stayed up in the air the whole time until it came to about here, we'll say. Okay. And I expect that there to be approximately 4.1, we'll say. So the answer that I put down there would be 4.1 seconds. So my answer, like I said, would be 4.1 seconds. And there was actually 5 marks going for that. So the last part of that question says, find the length of time the ball was 10 metres or more above the ground. So in order to find out how long it was 10 metres or more above the ground, we need to go back and look at our graph again. And we need to look at when it was 10 metres above the ground. So if we were to look at it, 10 metres is obviously here. So we're looking at everything inside here. So we're looking at this length of time. So between here and we'll say here. Okay. So we're going to estimate that's 3.4. And we'll estimate that this is 0.6. Okay, so approximately. So the length of time that's in the air, so it's going to be 3.4 seconds. Okay, so it's going to be this take away this. Okay, so the distance between those two there is going to be the length. So to find that length, 3.4 would be the full amount. But for the first 0.6 seconds, it's not above 10 meters. So you have to subtract it. So 3.4 take away 0.6. So the answer there will be 2.8 seconds. And that year was worth another 5 marks. Part D, right? So part D asks for it asks us to differentiate the function, right? So f of t is the function, and they're looking for f dash of t, which just means we need to differentiate it. So if we're going to differentiate it, we'll start off there by saying f dash of t is equal to, the 2 comes down in front, so it's going to be 2 times -4, which gives us -8. T, we'll reduce that power by 1. So when we reduce 2 by 1, it'll be just 1. We tend not to put in the 1. And then the 16t will turn into plus 16. And the reason behind that, I'll just do that here on the side, is because 16t is the same as 16t to the power of 1. So the 1 comes down and it'll be 1 times 16, which gives you 16. And the t will be reduced by 1, so that will turn into t to the power of 0. And t to the power of 0 is the same. Anything to the power of 0 is the same as having, is the same as 1, so it's the same as multiplying it by 1. So that gives us 16. Okay. In a similar fashion, we'll just look there at the 1. So 1 is the same as 1 times t to the power of 0. If we bring the 0 down, it'll be 0 times 1, which gives us 0. T to the power of -1, but anything multiplied by 0 gives you 0, so that's why the constant disappears. And just for completing that, you would have got 5 marks. So, part 2. Use your answer from part 1 to find the speed of the ball when it had been in the air for 4 seconds. Give your answer in meters per second. Okay? So, let's just go back and look at what we're actually looking at there, because it's important that we understand what we're doing. So, we had a graph and we got to see how the height changed with respect to time, right? When we differentiated that, what we found was how the height is changing with respect to time. So what we're actually finding is the speed, okay? So what we'll do is we'll just go back there and look. They want us to use the function to find out what I get at 4 seconds. So instead of t, I'm going to put in 4. So f dash of 4 will be equal to -8 times 4 plus 16, which gives us 8 times 4. So that will give us -32 plus 16. So that gives us -16 meters per second. So if we just go back in there and look at the diagram, we can see that after 4 seconds, we're at this point, and we're saying it's -16 meters per second. So you can see it's slowing down because it's negative. So -16 meters per second. But my actual answer I would just give as 16 meters per second. So the answer for that would be 16 meters per second. And again, there was 10 marks going for that. So, the last part there of that question was as follows, right? So, it says use your answer from part DI to find the value of t for which the ball was descending and travelling at a speed of 8 meters per second. Okay? So, use your answer for part 1, okay, which was the differentiated function, to find the value for t for which the ball was descending and travelling at a rate of speed of 8 meters per second. So, we just need to go back there and look at part 1. And if we looked at part 1, we could see there that what we got for part 1 was the rate of change, so the rate at which it's changing, which is f dash of t is equal to negative at plus 16. So that's the speed, the rate of change, I suppose. Okay, use your answer from part 1 to find the value of t for which the ball is descending. So if the ball is descending, it's obviously going to be a negative 8 in terms of speed, right? So speed is going to be equal to negative 8, and we need to find out what the rest is. So negative 8 is equal to negative 8t plus 16. Because you can see there it was descending at 8 meters per second. So that means it's negative 8, okay? So that gives us our negative 8 for our speed. And we're looking for a value for t. So let's bring the negative at over to the left-hand side, and it will turn into a positive at is equal to 16. And we're going to bring that negative 8 across, and it will turn into a positive 8. So at will be equal to 24. So t will be equal to, divide both sides by 8, and we'll get 3. So time is going to be equal to 3 seconds. And that there was worth a further 5 marks.